Whoa.
Yeah. Okay, so the first problem we're going to do is, actually I'll let you pick. Do you want to do polyprotic acids, a regular equilibrium one, or do you want to do something with salts? Something with salts, okay.
That's the part where I need the most support.
Okay, well before we do that, why don't you just tell me like what's the whole thing with like pH and salts? What did you guys talk about today?
Without looking at my notes.
If you need to, it's okay.
Okay, so salts can
notes.
affect the pH, obviously, if they're not connected to a strong acid or a strong base, like the conjugate of the anion is not a strong acid or a strong base.
Yes, yeah. So they don't need to be connected.
Right, I said it wrong the first time. The conjugate, it has to be the conjugate. I don't know why I'm keeping this as a topic.
It's okay. I know what you're saying. It's just the vocab is important, so I want to make sure we're saying it right. But so what is a salt? Do you actually know what the definition of a salt is?
Is it an anion and a cation?
Yeah, that's what it is. But a salt is the product of an acid-base reaction, right?
I didn't know.
Yeah. So like we have NaOH, strong acid, or strong base and strong acid. What does that give us?
Salt.
A salt, right?
NaCl.
NaCl and water. That's something just to remember in chemistry. Strong acid and strong base, always you do salt and water. How about KOH and I don't know, what's your other favorite strong acid?
HBr.
HBr. What's that going to give us?
Potassium bromic acid. Did I just make that up?
How about giving me the chemical formula?
KBr.
KBr, good. And
H2O.
okay, so now that you can see it written down, are you going to revise the name of that? KBr. You said potassium bromic acid.
Yeah, I made that.
That's okay. So how do we recognize acids?
So it's not an acid?
Well, you tell me, how do we recognize acids? There's 3 ways.
This is like basic stuff that I should be really strong in, and I'm just not. So.
It's always good to go back to the basics.
Yeah, especially since I'm probably gonna need it for test. So an acid. Well, first of all, the reason why I think it's an acid is because I think KOH is a base.
KOH is a base, yeah.
So, and I already said that hydrobromic acid is an acid.
Mm-hmm.
So that's why I think that's an acid.
So you're thinking in terms of like conjugate base, conjugate acid, right? Okay. So.
But this is going to do with like donating acid donates protons.
So, are you thinking? Okay. So, what are our 3 classifications? We have Arrhenius, right? What does Arrhenius say about acids?
No idea.
They are H+ donors. That's an Arrhenius definition. Bronsted-Lowry, I'm probably not spelling these totally right, but Bronsted-Lowry says something kind of similar, but a little bit different.
Proton donor.
Proton donor, yeah. Yeah, well, okay. I guess the Arrhenius is really more the things that have H+. Like things that have H+. Whereas these are things that give H+, which ties in because they say, what do they say about bases? Acids are proton donors. bases, proton acceptors. Yeah, okay, good. And there's one more that you guys haven't done, right? But we talked about it. So what is it? Lewis, yeah. And there's like a little rhyme for Lewis, remember?
No, I didn't teach me
AA, acids accept electrons. So a Lewis acid accepts electrons, kind of like H plus, right? We have H plus, and then we
it has to do with electrons.
then we have some minus, right? Well, the electrons are going to go there, and that gives us HA. Make sense? That's a Lewis. You'll see, I mean, they're all pretty much synonymous. It's just as you go down the list, they get more broad. So like, if you think about it, this is an acid, right? And this is an acid, and it works for all three definitions, but this is kind of the most basic form. So when you get into organic and you have something like, I don't know, giant proteins, it's like, well, what do we say about this, you know? So it really depends just on the situation you're looking at, but most of the time you're going to be thinking about Bronsted-Lowry.
Okay.
So let's go back up here to number, we'll call this just like equation 2. Okay, so we have KOH and HBr. So you already said that this is a strong base. And we already said that this is a strong acid. And now we're trying to identify these guys. So if we look at KBr, what are the charges on KBr? K is
+1.
Yeah, plus, and Br is minus, right? So if you think about it, this is going to have a lone pair on it, right?
How do you know that?
Well, because it's got a negative charge, so it's going to have 8 electrons, right?
Yeah.
Do you remember how that works? It's got full ones, it's got this, so they donate. Compounds. Should we review that, or do you remember?
I'm a little lost.
Okay, well, so basically we have an ion, right? So it's, let me pull up the periodic table. So if we're forming an ionic compound, something needs to give an electron and something needs to gain an electron, right? Periodic table. So, okay, so lithium is going to give us lithium is +1, right? Because it's in this column. This is all going to be plus.
Potassium though?
Yeah, whatever, potassium 2, K plus. Those are going to be +1, these are going to be +2. And the reason that ionic compounds are metal and non-metal is because you want this +1 and this -1. You want them to
Right, which is
ionize.
why I don't understand why there's a lone pair of 2. Wouldn't that be +2? Or -2, I mean, if you have 2.
I mean, I shouldn't have drawn the 2. Normally when you think in, I see why that's confusing. When you do organic chemistry, you think of like 2 electrons as going places, because 2 electrons is how you form a bond. But technically with K plus and Br, it looks like this. Like it's not really that, but
Right, like those 2 in the middle are kind of shared. Like one technically belongs over here, technically belongs over here, but they're shared feature.
that would be a covalent bond. Okay, so I see that this is misleading, and I apologize for that. But really, the idea that I'm trying to get across is that if you have something with electrons that can be donated, like Br normally has 7 electrons, right?
Right.
So when you get that 1 extra, that's where your negative charge comes from, right?
Yeah. So
having a negative charge means that you can donate electrons to form a bond.
Yep.
So this is a Lewis base. So technically, KBr is the conjugate base of HBr when you're thinking in terms of Lewis. This acts as a Lewis base.
Interesting.
But that's kind of getting away from the idea we're looking at here, because while this anion can act as a Lewis base, KBr is a salt. It's not going to act as either of those.
So it's not a base or an acid.
Yeah, it's a salt. The compound.
Okay, that's shitty.
Yeah, it is kind of confusing, but don't forget that this is just a one-way reaction.
Yeah.
One-way acid reaction. That's all it's acid base.
There's no conjugate anything. It's just a salt.
I mean, I guess technically, but this compound isn't an acid or a base. Make sense?
Yeah.
Because then that goes back to our rules, which is rule number 1 of like the pH. Salts of strong acids and strong bases don't hydrolyze.
Yeah.
So the pH of this is just 7, right?
Mm-hmm.
So it doesn't really work to say that these are acids and bases because the pH is 7.
Okay. I'm bored.
Make sense?
Yeah.
Think about like the autoionization of water.
Yeah.
You guys have talked about that, right?
Yeah.
2H2O is going to go to H3O plus OH minus. These are acids and bases, but the pH is just neutral. It's just going to be 7. This is pure water. Same thing up here. It's going to go to this, and like while you have like technically that's going to act as a base, and technically that can act as an acid. This is just the neutral solution. I know that's super funky, but this is kind of like what I was talking about before. I think I was talking to you about it. That it's like for this class, you really need to take everything into context. Because this is the class where you really start learning like how chemistry stuff works. So it's important to look at like the whole problem. It's like what's really going on here. This isn't a class you can memorize your way through.
Darn it.
Yeah. Make sense? Is this all good?
Mm-hmm.
Okay. So that's all this, and that's the first rule of like our salt base. The second one is that salts with strong base and a weak acid are going to give us a basic solution. So that's going to look like what? Give me a strong base.
Strong base. LiOH.
Yeah. What's the name of that?
Lithium hydroxide.
Good. I think you probably don't know any weak acids off the top of your head, so we'll just go with acetic acid. That's generally the go-to. CH3COOH. Acetic acid. That's a weak acid. It's an organic acid. So that's going to give us sodium acetate. Lithium, sorry. Yeah, lithium. We never uses lithium for the example. It's new, it's confusing. And water. Right?
Mm-hmm.
Is that right? Yeah. Okay. So this is going to give us a pH greater than 7 because this anion here acts as a base.
And that's because we have a strong acid over here.
Where do we have a
and
strong acid?
a strong base and a weak acid.
Acid. So this salt is the salt of a weak acid and strong base. So the pH is, it's going to form a basic solution over here.
This is a salt over lithium acetic acid.
Lithium acetate.
Lithium acetate.
Yeah. Because it's not an acid.
Right, it's a base. The salt. Salt.
It's a salt where the anion will act as a base. Kind of like we were talking about with the KBr thing. But this, I mean, this is a little different because it's reversible.
Right. This is a weak acid.
Yeah, and we have a weak acid, so it's a little different. Because, okay, I guess this is actually a good time to go back and talk about the things we were just talking about before. Because for this one, this can't go backwards, right?
Right.
So once it goes this way, you're done. So there's no more reaction that's going to happen here. So this can't act as an anion. Whereas here, this is reversible. So this can act as an anion. There we go. That's the difference. Okay. Yeah, makes sense?
Yeah.
So the third one is a weak base and a strong acid. So give me your favorite strong acid.
Strong acid. My favorite strong acid other than
Other than HBr, give me a new one.
I did not study these.
That's okay.
So, no, it's not okay. You told me to. So it would be, other than like HCl, which is the most used one, like KCl?
KCl and acid?
I don't know.
Well, what is KCl?
KCl is.
Does that fit into any of our acid definitions?
Doesn't have an H.
Doesn't have an H, so it
It's not a radius.
can't be that one, can't be that one.
And is it accepting an electron? I mean, Cl is negative and K is positive, but.
True. So Cl, the anion, could act as a base, except it's the product of strong acid and strong base. It's a salt of strong acid and strong base, so it's not.
We'll just use the HCl because that's the only one I have.
Good, yeah. HCl is fine. I know you have your notes though, so make some flashcards.
Yes, I already made the flashcard. I just studied it.
He's got to do it. I know. So you said HCl, and we'll use ammonia as our strong base. That's another one that people use a lot, or is our weak base. Sorry, weak base, not strong. So that's going to give us ammonium chloride and NH4Cl and just H+. And technically, yeah, if this is happening with water, you get H2O+, but because this reaction, ammonia is a gas, HCl, you see that gaseous HCl, but anyway, so that's what we got. And so here, this is going to give us pH greater than 7 because this cation acts as an acid. And so that's a salt of a weak base and strong acid. So the pH is going to be less than 7.
Yeah, that makes sense because if the acid is strong, then it's going to overpower the base. Then you get an acidic solution.
Okay, and so can you think what's our final situation?
After the equilibrium has settled out, you mean?
Okay, so kind of. So we looked at 3 different scenarios. We looked at the salt of a strong acid, a strong base, a weak acid, a strong base, strong acid, a weak base. So strong, 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 weak, weak, strong. There's one more.
Weak.
Weak.
We didn't do that yet.
Yeah, you guys haven't done that yet because that doesn't have like a hard and fast rule of it. That's something like this one depends on the specific Ka and Kb. So this is one we did do calculations with. So those are good situations to remember.
This last one comes out as a slip.
Which one?
The NH4Cl.
Yeah. Yeah. Okay, so why don't we actually do a couple problems now?
Okay, why not?
But you're good with the math, so let's do a theory one. And then then we can do math if you want. I still hold that the math is the least important part of the class. The theory is the hard part. Okay, so now we're going to look at a couple salts, like aqueous solutions, and you're going to tell me if they're acid, base, or neutral. Okay, so the first one is NaOCl, aqueous. Strong, basic, or neutral?
It's really similar to NaCl, but it's not.
It is, but what's the anion? Not you. If it's a call, you take it. This isn't like a class.
Is it OCl?
OCl, yeah, good. So that's cation or anion?
Anion.
Anion. And what's the cation?
Just Na.
Na. Okay, so we talked about salts of strong acids and strong bases. What's the base that goes along with sodium? When you normally think about it, does sodium sound like any strong base? Sodium hydroxide. So this isn't going to hydrolyze. That's not going to do anything. But this is a conjugate base, and that's going to be OCl minus plus H2O. And what's that going to give us? So, does this balance?
There's 2 O's and H2Cl. That's not.
Yeah, so this won't work. There's a much simpler reaction.
Cl minus and H2O2.
That'd be forming a peroxide. This is an acid-base reaction. So we're going to, at the end of this, we're going to have an acid in the base, right? Because this is an equilibrium. And we said that this is a conjugate base, which means this is a conjugate acid. So then we need an acid in the base over here. So if we have an anion, there's generally a simple way to make this an acid.
By adding an H.
By adding an H. Plus
OH.
what's the charge?
Minus.
Yep, there we go. And this is a base, right? So this is an acid-base reaction in equilibrium. And we know this is not a strong acid. So we need to look at that and figure out if this is acidic or basic. And so we saw that the anion is going to be reacting, right? So this is the salt of a strong base and a weak acid. Strong base and a weak acid. So what's that going to go to?
Strong base and weak acid goes basic.
Basic. Yes, this is a basic solution.
Why did you say it was a strong base again?
Sodium hydroxide.
Oh.
Right, because that's how you get Na plus, right?
So
Na.
you just took out the Na plus from the equation.
Well, it's just not going to react with water, right? That's just going to be more confusing. Don't worry about it. But yeah, does that make sense?
Yes.
Okay, let's do another one. Let's do KCl.
That's a salt.
That's a salt. What are the constituents of KCl?
K plus and Cl minus.
Right off the bat.
You know that just like with Na plus, K plus is like the conjugate of KOH.
Good. And Cl minus?
I don't know what you're getting at. It's
It's
an anion.
an anion. So what generates an anion? So we have something, and it's going to go to Cl minus plus another thing. Do you remember the generic equation for an acid?
HA goes to H plus A.
So what's the acid?
Cl minus. No, that's the base.
What is this compound?
HCl.
HCl, really good. And since this is a strong acid, this is a strong base, the salt of a strong acid and a strong base has a pH of 7. So this is neutral. Yeah, you're getting the hang of it. Okay. I don't want you to be late for your lab, so keep it on the time.
Yeah, no, I'm definitely.
But I'm not trying to kick you out. 150.
Yeah, but it's like literally in the classroom right there. So.
Yeah. Oh yeah, I'm not trying to kick you out. I just want to make sure you're keeping that on the time too. Labs are all about time management. Okay. Ammonium nitrate.
So that's a salt.
It's a salt.
And it comes from.
Well, before you tell me what it comes from, what's like the ion breakdown?
So NH4 plus and nitrates and 3 minus.
Okay. And what are these the conjugates of?
NH3 NO4.
NO4 would not be a positively charged, or wouldn't be a neutrally charged compound.
Okay, so it add up to 2.
Yeah.
So N2O3.
N2O3, that's like a weird hydrazine mix. Oh no, hydrazine, that's H's. That's rocket fuel. Hydrazine.
Okay, just be rocket fuel.
Yeah, this is rocket fuel.
I have no idea.
HNO3. That's a strong acid, nitric acid. So
that's why I need to memorize these things.
That's why you gotta memorize them. It's a strong acid and a weak base.
Strong.
Actually, yeah. So what's the hydrolysis reaction here? NH4 plus OH minus goes to NH3 plus H2O. Right. That's
Work on your handwriting a little bit.
Yeah. NH4 plus OH minus goes to NH3 plus H2O.
Yeah.
So, so it is right. My bad. I actually wrote this equation wrong. My bad. Sorry. NH4 plus H2O. This is the thing that's hydrolyzing, undergoing hydrolysis. Yeah, here we go. Okay.
But that doesn't have the H and the hydrogen.
So what is this reaction here? Is this acid neutralization?
No, acid.
NH4 is an acid, yeah. So an acid's being neutralized. So this is like a basic reaction. Wait. This is an acidic reaction, excuse me, because this is an acid. So this is an acidic reaction, which means H3O plus is greater than the concentration of OH minus. Yeah, this is an acidic reaction, so that means it's acidic. Yeah, these are kind of tricky, but if you do enough of them. Questions, comments, concerns?
Well, you mentioned, the HNO3, but then didn't put it in the equation.
Right, because
We just have to know that that's a weak base and a strong acid.
yeah, you should know the strong acids and strong bases. So remember, if it comes from a strong acid or a strong base, it's not going to participate in the reaction.
Okay.
In the hydrolysis reaction with water.
Right. Yes, the NO3 doesn't participate.
Yeah. So
Because I know those strong acids eventually.
Because you studied those. Yeah.
I will study them.
Yeah.
Then I would know that belongs to. Okay. So
You're getting it though. Every time you solve a problem, I can see the wheels turning. You're getting it.
Yeah, and this is a really convenient time for me because I have like the class and then the lab, and it's just easy.
And I know it's not the most fun time to study, but right after the class is the best time to study.
So I'm connecting like what he said, which made total sense until I get here, and then I have to be tested on it. So.
That's why everybody should come that summer. I'm gonna start being more annoying in class. I'm
Like stand up.
yeah, I'm like, yo, come to the SI session, blah, 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 blah. And then I might switch the other one.
She said people were coming to.
Yeah, some people come sometimes, but I think it'd just be easier. Plus, like, that one is right after you guys have an exam.
Yeah.
Whereas like most people come exam week, and I think it'd be easier to have 2 right before the exam. Yeah. Like one before class, then you guys can go to class, and then right after that class, and then your exam. Plus, I have a lot of stuff to do on Friday, so I can use the Thursday nights to study. Which means I'll be more prepared for the SI sessions too. Because then you guys can send me stuff over the weekend, and I can prepare.
Gotcha.
Making sense?
Yeah, I think I learned a lot.
Before, I'm gonna check with the professor to make sure it's okay, but I'll probably scan all of like the problems and notes that I take and send them to you guys.
That'd be nice.
Like after the last review session, before the exam.
Yep.
I'll probably scan these and send them to you guys if it's cool with the professor.
I mean, it's your own work, right? So.
I mean, it is my own work, but there are also like examples from the book and things like that with problems.
So I don't see why that wouldn't be okay.
I mean,
It's not like you're taking it directly from his exam and like sending us his exam.
No, but I don't want to get in trouble.
So that's the last.
Yeah, it's better to ask.
Yeah. All right. See you next week.
Yeah, see you next week. Okay, I don't know if anyone's listening, but I'm going to stick around for a little while in case you want to show up. So I will see you soon, hopefully. If not, I will see you guys next week, or I will see you in lecture, or at the Thursday night one. Come to the Thursday night one.